Welcome to day 25 of Math 111. In this lesson, we'll be considering fractions and rational numbers. First of all, what do we mean by a fraction of the form a over b? First of all, there must be an agreed upon unit. Second, the unit must be divided into b parts of equal size. And number three, there are a parts of the unit under consideration. These three assumptions are very important. Here's an example. 2/5 of a pizza implies that the pizza is the unit. The pizza has been divided into 5 pieces of equal size, and we are considering 2 of those 5 pieces. Here's a formal definition for a fraction. A fraction is an ordered pair of integers a and b, where b is not equal to 0, written as a over b. The integer a is called the numerator of the fraction, and the integer b is called the denominator of the fraction. We have several different models when we consider fractions. The first one is the area model. In this model, we typically color regions. Notice in each of these examples that the unit is given, and then colored portions are displayed there. So in the one on the left, you've got this circle. The circle has been divided into 4 parts. Notice that the parts are all equal size. One part is colored. The circle is the unit. The circle has been divided into equal parts. One of those units is colored. This represents 1/4. In the example in the middle, you'll notice it is a diagram of the fraction 7/6. The hexagon is the unit. The hexagon has been divided into 6 equal parts, and we're talking about 7 of those parts. So we need a second hexagon, a second copy of our unit. We color 7 of the parts. Another model is with fraction strips. With this type model, you have a long, narrow rectangle. The rectangle is the unit, and then the rectangle is divided into equal parts. You can see how the rectangle has been divided to display several different fractions here. Another type model is with fraction circles. The circle is the unit. The circle is divided into equal parts, and then we color some of those parts. Notice in the diagram on the left, we have a display of 3/4. The circle has been divided into 4 equal parts, and 3 parts have been colored. In the diagram on the right, we're displaying 8/6. The circle is the unit. The circle has been divided into 6 equal parts, and we are considering 8 of those parts. So we need a second copy of our unit, and we have 8 parts colored. Another model is the set model. Here you see a diagram that contains 10 apples. 3 of the apples have a worm. Those 3 apples have been enclosed in a loop. This is a diagram displaying 3/10. The number line model is also something that we should consider. On the number line model, the distance between 0 and 1 is the unit. With the number line model, it is easy to show that a particular number can be expressed with different fractions. Notice in the number line in the lower right of your screen that we are displaying how to show both positive and negative fractions. Positive fractions have an arrow that moves to the right. Negative fractions have an arrow that moves to the left. When we talk about fractions, we sometimes need to know about equivalent fractions. The number line model is very useful in showing that a number can be expressed with several different fractions. Fraction strips and fraction circles are also useful for this concept. Notice here that 2/3, 4/6, 6/9, and 8/12 represent the same colored area on the fraction strip. Let's look at the fundamental law of fractions. Let A over B be a fraction. Then A over B is equal to A times N over B times N for any integer N which is not equal to 0. What we're seeing here is that we can multiply the numerator and denominator by the same number, and the fraction remains equivalent to the original. We have an example at the bottom. 7/9. We can multiply both the numerator and denominator by 2. This gives us the fraction 14 over 18. 14/18 is the equivalent to 7/9. We can also consider this law from right to left. We use this when we simplify a fraction. In the example at the bottom, you can see what we're talking about. We start with the fraction 24/36. We know that 24 and 36 have a common factor. 12 is a common factor of both 24 and 36. 24 can be written as 2 times 12. 36 can be written as 3 times 12. And so, using the law, we know that this is equivalent to 2/3. Therefore, 24/36 is equivalent to 2/3. We have a cross-product property of equivalent fractions. It reads like this. The fractions A over B and C over D are equivalent if and only if A times D is equal to B times C. Here's an example. 50/75 and 2/3 are equivalent. When we multiply 50 and 3, we get 150. When we multiply 75 and 2, we also get 150. Because of this, we know that these fractions are equivalent. Once we know that fractions are equivalent, we can join them with an equal sign, as you can see in the bottom line here. A fraction A over B is in simplest form if A and B have no common divisor larger than 1 and B is positive. In order to determine the simplest form of a fraction, one method is to divide both the numerator and denominator successively by common factors. Another method is to determine the greatest common factor of the numerator and denominator and then divide both the numerator and denominator by the greatest common factor. When fractions have the same denominator, we say that they have a common denominator. Let's think about this for a moment. Consider the fractions 3/4 and 5/6, which do not have a common denominator. One method of rewriting the fractions with a common denominator is to use the product of the existing denominators. The denominators are 4 and 6, and their product is 24. So we can begin with 3/4 and multiply both the numerator and denominator of 3/4 by 6. This will give us 18/24. We can take the fraction 5/6 and multiply both the numerator and denominator by 4. This will give us 20/24. Now you can see that the two fractions have the same denominator. I want you to note that in each case, we're multiplying the fraction by a quantity equivalent to 1. In the first fraction, 3/4, we multiplied by 6/6. And in the second fraction, we multiplied by 4/4. These are equivalent to 1. Let's think about another technique for finding a common denominator. Let's again consider our fractions 3/4 and 5/6. We want to use the least common denominator this time. In order to do this, we need to know the least common multiple of 4 and 6. The least common multiple of 4 and 6 is 12. We have talked about this before, so you may need to review how to find the least common multiple. We first consider the fraction 3/4. I want my denominator to move to 12. So I'll need to multiply 4 by 3 in order to get 12. I'll multiply the numerator by the same quantity. So I'm multiplying the numerator by 3 and the denominator by 3. This gives me the fraction 9/12. Let's move to the second fraction, 5/6. I need to convert the 6 into a 12. That means I need to multiply it by 2. So I'll multiply both the numerator and denominator by 2. 5 times 2 is 10, 6 times 2 is 12, and I get the fraction 10/12. So now I have fractions with a common denominator, 9/12 and 10/12. Both have a denominator of 12. Let's talk about a rational number. A rational number is a number that can be expressed by a fraction a over b, where a and b are integers and b is not equal to 0. We have a symbol for the set of rational numbers. It is the capital Q. We can order rational numbers, just like we can order integers. If the rational numbers have a common denominator, then the numerators can be compared. For instance, we have this example, 5/12 and 7/12. Both have a denominator of 12. Because 5 is less than 7, we know that 5/12 is less than 7/12. If the rational numbers have the same numerator, then the denominators can be compared. Let's look at an example like that. We have 5/8 and 5/6. We know that 1/6 of a unit is larger than 1/8 of the same unit. Therefore, 5/6 will be greater than 5/8. So 5/8 is the smaller of the two fractions. Let's look at this property here. Let two rational numbers be represented by the fractions a over b and c over d, with b and d positive. So we're saying that our denominators must be positive here. Then a over b is less than c over d if and only if a times d is less than b times c. We've got the product of the extremes and the product of the means. A and d are the extremes, b and c are the means. And so if we have this relationship, a times d is less than b times c, we know that the fractions have this relationship, a over b is less than c over d. So here's a sample problem. You might see something like this in your homework. Order the rational numbers from least to greatest. We have 3/5 and 7/12. Which one is the smaller one? I'll multiply diagonally. 3 times 12 is 36. 5 times 7 is 35. 36 is greater than 35. So 3/5 is going to be greater than 7/12. The product of the extremes is greater here. That's why I have the first fraction greater than the second fraction. The concepts in this lesson are very important. The concepts about fractions and also rational numbers are useful in other areas of mathematics. Being able to find a common denominator is very important because when we add and subtract fractions, we need a common denominator. Make sure that you have mastered this skill.